let's take a look at how to solve the section 3.2 gas laws math skills that we had. So first things first, we've got two formulas that we're going to be using. The first one is called Charles' law. And that formula is volume 1 over temperature 1 equals volume 2 over temperature 2.
That's okay. We just make sure that.
All right. The other one is Boyle's law.
All right.
And this formula is pressure 1 times volume 1 equals pressure 2 times volume 2. Now, we do have a version of this formula that is really just a combination of the two. And so when we look at the combined gas law formula, you can see that it is just the two formulas put together. And so it would be pressure 1 times volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. All right, so that's the formulas that we're going to be working with. And so now when we look at the problems, we want to identify what information we're given and then pick the appropriate formula. So let's take a look at exercise number 1. So it says, at a given temperature, gas with a pressure of 150 kilopascals has a volume of 0.8 liters. So let's look at that and talk about that. So that's gas number 1. Okay, so for number 1, we have pressure 1 is equal to 150 kilopascals. And then it says that volume 1 is equal to 0.8 liters. And then it says if the pressure decreases to 75 kilopascals and the temperature remains the same, what will be the volume of the gas? So that temperature remains the same is kind of a key little issue. So let's take a look first. We're going to reduce the pressure. So pressure 2 is going to be equal to 75 kilopascals. And so our unknown that it asks us for is what's the volume of the gas going to be? So volume 2 is our unknown. All right? And then it says temperature remains the same. So because temperature remains the same, we don't need to worry about temperature. We can discard it. Also, look at what we're given. So we're given pressure, volume, pressure, and we're trying to find volume. And that's where we're looking at the Boyle's law equation. So now, once we've identified that, the first thing we're going to do is write our formula. P1 V1 equals P2 V2. And I do this every time as a step to make sure I don't make any errors. And now what I'm going to do is just right below all of the information that I have here. So P1 is 150 kilopascals. And V1 is 0.8 liters. And that's equal to P2, which is 75 kilopascals. And then that's multiplied times our unknown, which is volume 2. So now it's really just a simple matter of algebra. And so I'm going to open up my calculator. And I'm going to say 150 times 0.8. Okay, so that's this. So I'm going to simplify that. And that's going to be 120 kilopascals
Okay, good.
times liters. and then continue over here, 75
plus 5
kilopascals
has to be 7.
times volume 2. And so now we need to divide both sides by 75 kilopascals.
What you have on there.
So
number 2, when I have
write it like
divided
this.
bases, for example, s squared divided by s to the 5th.
And so now 75 kilopascals times volume 2 divided by 75 kilopascals, that just cancels that out.
So it adds,
And now I just need to calculate what's 120 divided by 75. So 120 divided by 75 equals 1.6, and then kilopascals
which one am I going to
divided by kilopascals cancels out, and I'm left with liters. So my volume 2
Let's review this one. When I multiply
is 1.6 liters.